Hey guys, today we're going to be doing 2sum2 input arrays sorted. This is a common question currently asked by Google and Amazon. Let's get to it.
I go back to the club with my troops, with a bad bitch that's on my side looking like hoops. Up in the club, rolling the dub, who got the flavor looking like flavor.
Hey guys, so this is actually a really common interview question, and even if you're not asked this question verbatim, it's pretty common that you'll see a much larger problem and you'll want to decrease your problem space to this 2sum2 input array is sorted. So let's look at the problem description. It says, given an array that is already sorted in ascending order, find two numbers such that they add up to a specific target number. So description is, find two numbers such that they add up to a specific target. And then we have two notes. It first says the function 2sum should return indices of the two numbers such that they add up to the target where index 1 must be less than index 2. Note 1 is your returned answer. Both index 1 and index 2 are non-zero based, and you may assume that we have exactly one solution, and you may not use the same element twice. Cool, so we're given two arguments. The first argument is nums, a list of integers where the integers are in ascending order, and arg2, target, and this is an integer that we're trying to add up our numbers to. And then, like was said in the note, we're going to have some return value. I'm just going to call it ret, and in this case, ret is going to have index 1 and index 2 adding up to target where index 1 is less than index 2. So let's try to understand the inputs and the outputs real quick. So in the example given, the input 2, 7, 11, and 15 and the target 9 would give us output 1 and 2. And this is because the first index, which is 2, plus the second index, which is 7, would give us the target of 9. But then if we change this target to 13, or 11, 13 rather, we'd want to make our output 1 and 3, because index 1, which is 2, plus index 3, which is 11, would sum up to our target of 13. So let's try to think of a few approaches to do this. So the first approach would be brute force. We could just have some double for loop for x in nums, for y in nums. If x plus y is equal to target, then return x and y. But this would give us an O of n squared time, and it would give us an O of 1 space. That's a pretty good space, but we can probably do better in terms of time. So our approach to is that we could just use a set, and this set, using a set is pretty similar to the regular 2sum, and this would give us O of n time and O of n space, the space to create a set, but we can probably do better than this, and then this makes it a little tricky when we're trying to return the indices of these values. So this brings us to approach 3, and this is the two-pointer approach. And you'll see the two-pointer approach used a lot when you want to try to reduce your space complexity while staying at the same time complexity in a lot of problems. It's used in the balanced parentheses problem. It's used in a lot of famous problems. So essentially, if we're using a two-pointer approach, the way that this could look is we have, and I'm just going to take this input, we could have two pointers, A, I'll just call it for simplicity, and B. And essentially, the way that we can do this is we can have some while condition, while not termination condition. And I'll make my termination condition, because it's assumed that we're always going to have one answer, I'll make my termination condition while value, so while nums at A plus nums at B is not equal to target. So we'll just keep moving while that. So our case under this while condition is if we're less than our target, we want to increment both pointers forward. So right now we're less than our target. So if less than target, increment forward. And then now we incremented those forward in this case, but now we have our current values 18. So then if greater than target, increment A backward. So what we do here is that we'd increment this backwards, and then all of a sudden we'd have 11 and 2, and this would give us 13, and then we can return A and B. So this is a great solution because it'll give us O of n time and O of 1 space because we're not actually allocating any additional space. So let's code this up. So like I said before, we're going to have pointers A and pointer B. I don't want to use the variable names A and B because I think that's a little ugly, so I'm going to do P1 and P2. I'm going to set that to 0 and 1. And then our termination condition is well, nums at P1 plus nums at P2 is not equal to target if nums at P1 plus nums at P2 is less than target, P1 plus equals 1, P2 plus equals 1, and then else P1 minus equals 1. So this is this case where we're walking backwards. And then at the end, when we finally find a P1 plus P2 equal to our target, we want to return P1 comma P2. Because once we have P1 plus P2 equaling our target, we can just leave this while loop and then return P1 comma P2. So let's see if this runs. It's taking a sec. Okay, so the reason that this is 1 off is because this is saying that index 0 is actually 1. So essentially all we need to do to change this is add 1. And then I'm pretty confident that we can just submit this and then it will work. Awesome, so we got 64 millisecond runtime. That's faster than 67% of Python 3 users and 13.5 megabyte memory, and that's 80% better than Python 3 users. So cool, I hope you guys liked that. I hope that was helpful. If you have any other questions you want me to do, leave it in the comments below. And if you like this, please like and subscribe, and subscribe to my Patreon to see more. Thanks so much, guys. Peace.